This is section 7.1, Systems of Linear Equations. For the first two problems, we need to determine whether each ordered pair is a solution to the system of linear equations. For this, we would plug in the ordered pair. So let me make this a little bit bigger. So 6 is your x, 5 is your y. We're going to plug those into both of the equations. So the first one, 11 is equal to 11, is true. The point has to make both of the equations true in order for it to be a solution. So again, I'm going to plug it in to the second one. You're going to put the left side in your calculator. Okay, and I get 27, which is also true. So since that point makes both of the equations true, it is a solution. So for systems of equations, you can have one solution, no solution, or infinitely many solutions. Let's try this one. Let's plug that in to the first equation. Okay, so that one is true. Let's plug it into the second one. See if that's equal to 27. All right, that's equal to 26. So 26 is not equal to 27. Since both of those aren't true, both of those would have to be true. It's not a solution. So that point is where these two lines would intersect. Let's do the same for this one. 7 is our x. Again, 5 is our y. Now in the calculator, I'm just putting the left side in to evaluate it. So I get 9. So the first equation is true. Let's plug 7 and 5 into the second one. Seven. That's 22. Both of those equations are true at that point, so yes, that one is a solution. Let's go to our second one, our second point, and plug in our x and y. I just did that one real quick in my head. You can always use your calculator just for the left side. That one is not true, so this is not a solution because again, it has to make both of the equations true. All right, we're going to solve this system by graphing. If the system does not have a single solution, state whether the system is inconsistent or dependent. So there's a little trick here we can use. We can actually use your calculator to see if they have a point in common. So let's put this in. So some of you may remember this. You're going to hit Menu, Algebra, solve a system of linear equations. What's nice with the video is you can stop and pause these and go back. So menu, algebra, solve system of linear equations. Menu, algebra, solve system of linear equations. This right here, this dialog box, we're not going to change anything in there. So we're just going to click OK. With this function, we can put the two equations in. And we did this in 1020, so it may look familiar. This does have one solution. It's at the point 2, 1. Let me double check. I think it's at negative, yeah. 2, negative 1. So that's the point where these two lines intersect. They have that point in common. So this one is a consistent system. All right, so on this, they are going to want you to graph both of the lines. So I'm going to change my colors real quick. So for this first one, I know I can already use the point 2, negative 1. That's what they have in common. So I'm just going to plug in, let's plug in, let's let x equal 0. Just randomly picking a point. I know I have the point 2, negative 1. Let's plug in a 0 and see what we get. So it goes to 0, so y is equal to 5. So that is a second point that you can use for that line. Let's go to the second equation. So again, it has the point 2, negative 1. Get a little bit clearer because that's the point they have in common. Let's try plugging in 0 for x again and see if that's going to work out for us. We don't want a fraction. We want to end up with a whole number. Let's do a negative 4y equals 12. And pull this down just a little bit. So divide each side through by negative 4. At this point, you should be able to do this. So that point is at 0, negative 3. From here, I'm going to graph these. So let's graph that green one I did first. So we had a point at 2, negative 1, so over 2, down 1. And then we had a point at 0, over 0, up 5. 2, 3. I don't draw straight lines very well, so you'll have to forgive me. Let's work on our second one. It also had the point 2, negative 1, and a point at 0, over 0, down 3. And graphing points is something you should have picked up or reviewed in 1020. Move on to our next one. And I'll say this a few more times. Just remember that this is a video, so you can move back and forth, pause it if you need to look at things again or slow them down. All right, so this one we want to put into our linear solve and see if they have a point in common. Menu, algebra, solve systems. Everything stays the same. And if they're using lowercase, make sure you use lowercase when you type things in your key. Your keypad on your calculator will default to lowercase. So that one crosses at the point 80. It only has one solution at 80. Excuse me, 80. That means the system is consistent. All right, so we're in the first equation. We have a point at 80. And I'm going to try plugging in 0 for x. It's just a coincidence they happen to be inverted there. For the second equation, it also has the point 80, but let's plug 0 in there for x. A 0 doesn't have a sign on it, so negative 0 is just 0. It goes away. So y is equal to negative 8. Now it's time to graph these. We do the first one in a different color. So over 8 up 0. And then over 0 up 8. And let's choose a different color for the second line. That also has a point at 80. That's where these two lines are going to intersect. And it also has one at 0, negative 8. Oh, excuse me there. I don't know what I did. Okay. And just a reminder, I know those of you that had me before, you do remember some of the graphing. When you get into my MathLab to graph, remember you're going to select the line tool. Then you're going to move your cursor around and you don't click until you're exactly at 80. And then you'll graph the second point like 0, 8. When you're at 0, 8, then you click. If you're having trouble graphing in my MathLab, send me an email real quick and I can just do a really quick video and show you how to graph if you've not done it before. Okay, but if you were at Northwestern, you should know how to do it already, but it's all right if you forgot. So let's do this one. Flip back here. Negative x plus 4. X plus 5. Okay, and just a little note, if you've not really dealt with this calculator a lot, as I'm hitting the keys, like I'm hitting a 2, you see it will turn red on the keypad on the left. And flip back over here real quick, -5. Okay, it turns red, hit the 5. So that's like, if you're like, I don't know where the key is, just kind of watch and they will turn red as I'm using this calculator here. So those cross at the 0.31. So they have the 0.31 in common. That means they are consistent. So again, let's start with this top line. We know it crosses the 0.31, and let's plug a 0 in. That goes away, and y is just equal to 4. For the second line, the same thing. They have the 0.31 in common. And then just plug in a 0. 0 is usually the easiest one to plug in to start with. All right, that's going to go away. So y is equal to -5. Same process again. We go over 3 up 1, over 0 up 4. Our second line, again, we have that 0.31 in common. And then you would go over 0 and down 5. Okay. Oops, you can pretend that's straight. So once you graph this first one, you've selected the line tool. You will have to select the line tool, click on it again to put the second line in. It only lets you use 2 points to graph a line. So once you get the first one, click the line tool again, and then graph the second line. Okay. So we're going to put this one in. All right, the point, oh, same one, point they have in common is 3, 1. Since they just have 1 point in common, they are consistent. And I'm going to show you examples of the other two. All right, so again, with that first line on top, we have the 0.31. I'm going to try plugging a 0 in. So I end up with -y is equal to 5. To make y positive, I'm going to divide out a -1. And all that does is change the signs of everything. So we have a point at 0, -5. So for the second line, we use the 0.31. That's where they intersect. And let's try a 0. Well, there's no x here. So no matter what x is, y is always 1. I'm the graph, so we are going to change our colors up a little bit. So over 3 up 1, over 0 down 5. There we go. And the next one, it's one of those oddball cases. So over 3 up 1, over 0 up 1. So that one is a horizontal line. All right. So on a side note here, all right. So if it is inconsistent, those lines are parallel. When you put the two lines in the calculator, it will say no solution. That's if it's inconsistent. If the two lines are dependent, that's the same line. So it lies on top of itself. It's infinitely many solutions. And in the calculator, you get something weird. You get like C1, C2, and I'm going to show you a couple of those. I'm just going to make a couple up. We're not going to work that last one. All right, we want ones that are parallel. Parallel lines have the same slope. So no solution found, they don't ever cross. There's no solution. Those are inconsistent. So let's see one. It looks like, oops, did not mean to do that. You don't want to change this number. If you hit the tab on your calculator, it'll take you down to okay. It's not really a trick, it's a little shortcut. All right, and same line. Okay, you get something weird, like this says C1. It doesn't necessarily have to be over the 3 or the 4/3. It's that bolded C. That's what you want to look for. That would be an example of the same line, infinitely many solutions. So whatever makes the whatever would make the first one true is always going to make the second one true. So whatever point lies on this first line, it will also lie on the second line because the line is lying on top of itself. Okay, and that is it for section 7.1. Don't worry about doing this one here. We did a couple already, and that should be good.